Welcome back from the lunch break. I hope I can wake you up a bit. My name is David Will. I'm the General Director of DRÄXLMAIER Vietnam. DRÄXLMAIER Vietnam is a manufacturing company mainly with some development. What I bring today is this perspective of the end user, if you might say, a plant manager. And my view on the vision of AI we are seeing and the reality of AI that we are seeing at the moment here. So what is DRÄXLMAIER first? Automotive supplier from Lower Bavaria. Few of you will know it because we are doing B2B business mainly with German automotive corporations. However, we have 65,000 employees and turnover about 5 billion euros. References you see here, and the main business segments are interior, electrics, components, and batteries. We speak about that in a second. The business field I'm working in, and the reason why we are in Vietnam, is this product here. This is a wiring harness for automobile. Roughly 70% of the value add is man-made, not machine-made. So one of the reasons to choose Vietnam as a production hub is the requirement of manual labor in here, right? So we have a bit, the product itself triggers a different digitization and automation strategy than many other companies in the automotive field. So we have learned before that there's a high degree of robots in automotive, especially this industry is relatively low tech. And my perspective now is coming from that specific product in that specific industry and trying to evaluate how things are helpful and how they are not helpful in our industry. Those are the other products, interior. Most of you have seen those products. Many BMWs and Mercedes, you find instrument panels and door panels from DRÄXLMAIER. Electronic components also very prominent in German cars from us. Nearly every BMW who has a high voltage system has also DRÄXLMAIER parts. That's a battery system. This is actually the Porsche Taycan core. So we are supplying high voltage battery packs for the premium automotive as well. That's the footprint, Vietnam. We are supplying both China and Southeast Asia with our products here. Interesting maybe that we needed to establish this organization here in Vietnam because the cost pressure even in China for manual work went so high. So we are actually moving industrial capacity from China down to Vietnam here. But that's only as a side note. Let's see. All right, let's talk about artificial intelligence in manufacturing. I think the holy grail or the AI wonderland that we have heard before is the dark factory. A factory that can run without any human interference, that can run 24/7. On the weekend, no holidays, no public holidays, no strikes. That is what a lot of people are dreaming of, I believe. That is a very far vision from what I can tell coming out of manufacturing. And I'm not sure if any of us will experience that in its lifetime. There are Chinese factories that claim to be dark factories, but anybody who has ever worked with maintenance will probably say impossible on the long run. It's probably about hours and not days, how a factory can really run in that mode. So that's the vision. The automotive industry is quite active in application of intelligent AI. In vehicle development and production, we will see that in a bit, but also driver assistance, autonomous driving, user experience, which will get more and more important in automotive because driver assistance will free up your time in your car, and therefore there is an entertainment need in the car in the future. So we see investment here as well, and let's say supporting measures as well to increase efficiency and productivity in general in the industry. So first question I ask myself is, how is cable manufacturing, that's our product, how does ChatGPT, how does AI see the future of our industry? And I have to say it's not quite different to the current way we are producing wires here. It looks a bit like a dark factory, but I think that's a mistake from ChatGPT. What we see, and when we talk about automation and Industry 4.0, computer vision cameras, automized quality inspection, and man-machine interaction, and that's about it in ChatGPT. If we ask Microsoft Copilot what the future would be, the vision in the how it sees it, we see more headsets, work instructions, and-on boards, computer vision cameras, predictive maintenance, and other tools. But we still see the people, obviously, right? So for us, most of those tools are already implemented in the factory already. I think in every automotive factory you would implement that already to some degree. So really guiding us how the future of automotive looks like in AI, especially in manufacturing, apart from this very far vision, I haven't seen yet. So how do we now try to address this field, this trend as an organization? We see AI as a catalyst for digital transformation, helping us to be more efficient and productive, right? It is about empowerment for everybody to use the leverages that we hope artificial intelligence has and holds. For me, one thing is missing, a clear direction in our own vision, as you can see. So the target actually has not yet been defined. We are not yet at a stage as an organization to say, okay, and we want to get to this point within the next 10 years. I think we are still in an experimentation phase, looking at such a vision, and we will see that later in a model. Or in other words, the vision is a catalyst. We are not ahead of the game. We are not spearheading artificial intelligence. We're trying to be fast follower. And it's about an enablement of the workforce, hoping that we create the necessary critical mass in the organization actually to ignite the development. And let's say the process optimization. Some of you might know this model, Gartner model, about AI maturity. It's quite old, it's actually before COVID, and it defines different levels of AI maturity, from transformational, systemic, operational, active, and then some awareness. And judging from myself, I think my organization is somewhere between active and operational. I think everybody is aware of AI now. Everybody is using it every time you're Googling. But are we fully embracing the topic in the organization? Obviously not yet. We do not. We will be seeing, and this is what I'm going to show you in a minute, a couple of examples of islands, of experiments that we do inside the organization to come to a higher level of AI adoption, which would be then systemic. I'll skip that. Interestingly, we have two fields in DRÄXLMAIER, or in every company probably, office applications and applications in manufacturing. And I feel like we are significantly more developed in office applications, especially with the Gen AI models and the bots, agents, than we are in manufacturing, and you will see that in a second. So I'm just presenting you a couple of examples now that might be helpful for your own organizations that have been successfully implemented. Simple but effective incident classification in IT ticketing systems, obviously. I just run through them quickly in order to come to the manufacturing bits. Oh, sorry, that was too fast. More advanced application would be to combine text generation in patterns in this time and a workflow support. So, and this is actually saving high value time for lawyers in the organization to automatically draft patents, defenseless disclosures, and other documents, and support this document creation by workflows, which are AI supported. So we're getting more complex here in the application. The next one, and we are probably getting overtaken now by ChatGPT in the organization, or Copilot, is to allow AI to analyze different sources of information inside the organization and build its models from that, and use as a powerful search tool inside the organization, using DRÄX. The next step that we do together with Microsoft is to make more so-called agents available for the organization. So the organization will be capable of building agents itself in order to automate administrative processes. And we are pretty close to this. We're working closely with Microsoft Munich about that. And it seems to be quite promising. And I do see applications even in my plant, to be honest. When you think about logistics controls, material ordering, production control, everything that works with words and numbers, we do see tremendous potential here. So, office space quite developed, I would say. But manufacturing, still in experimentation. I will show you a couple of examples how that could look like. I'm just going into the example here. What you see here is a shunt, an electronic component. And the question is, the problem is the air intakes in production. How do you measure them? How do you define a defective or non-defective product? By applying CNNs, visual analysis of a computer part, and then defect detection here. So as soon as you have too many air intakes in a product, AI would analyze through a CNN and then detect the defect in those cases. Very helpful for mass production, obviously, right? Where you only have one single product that you are analyzing, which low variation. The only variation you have in this product is basically the defect, which is quite helpful. Another example is a Bowden cable. This is something you know from your bike. It is actually when you pull it and you will activate your brake. That's a Bowden cable. The question is if it has really locked properly. Also mass-produced, also inside a door in this case. No, it's actually in the fuel system. Can be analyzed as well. Relatively easy, two-dimensional picture is totally sufficient. So easy application, I would say. Another application is predictive maintenance. So you collect machine data you have anyways. This is interior production. In injection molding processes, you have vibrations. You measure those vibrations and you build a model to predict failure in the process and the requirement for maintenance in that process. Those tools are extremely expensive, and normally you don't have redundancies in the injection molding process for instruments panels, for example. So reducing maintenance time through AI, through predictive AI, seems to be quite promising for us, or is promising for us. Second last example, this is the wiring harness of an average premium automotive SUV. And you can see, and this is also the reason we don't automate the production of this piece. The only part which is automized is cutting the wires at a specific length and then building a terminal, putting a terminal at the end. The rest is manual work. So what does manual work mean? You have to manually take the cable and put it to the right spot. Then you add a connector at the end, and then you tape it. That's a standard process in the worldwide in the industry. Why is that? Because there's huge amount of variation in the product itself, very different steps, plus depending on your choice as a customer, I want seat heating, I don't want seat heating, I want this and that. This product changes. So you have a huge variation in the product. With 70% of manual labor in that product, at the same time you have a huge risk for defects, which is very difficult to control. So what we are developing right now is tools that help us to identify critical areas on the harness that can then be photographed or filmed and then analyzed for, let's say, process compliance. Let's see if that works. Yes. So we would be using AI to identify positions on the harness which are problematic. This is obviously from our Chinese colleagues. Here, the process has worked well, all green. And everything the eye sees is suspicious would then be marked. The next step in the production process would then to interrupt forwarding this product to the customer and putting it into a rework area. Let's say it's easy to explain, simple, right? You train a model for this location to understand if this clip has actually been inserted or not. But the whole development has taken over 1 year, together with a major industrial partner, in order to get to that stage, and it's not even fully rolled out yet. Another example is something we are trying here in Vietnam. One thing is picture detection, and the other one is process monitoring. And what we try to do here is already detect defects during the production process. There's multiple positions in the harness. This is a smaller cockpit harness, which require work steps you cannot really control later with automatic means on so-called test stations. Those would be clip direction or tapes, which are relevant for the customer and for the quality of the product, but are difficult to test automatically. So the question is, can we monitor the worker producing that part with AI to ensure process compliance? And later to eliminate checking every single piece for existent in an electronic system. So we have parts we cannot control, and we have parts which are lengthy to control inside the production process. How could that look like? So what you see here is an assembly board. There's two workers on the two sides. They have already finished their task. Obviously, we can be a bit more efficient here. The board will move. This is the semi-finished product. The worker starts operating. So as you can see, there's a lot of manual activities necessary in this tact on this station. They are assembling now so-called clips, and he was taping. And this is just a demonstrator. The aim is now to observe every single production step analyze what has happened, and then mark it. So this is a not finished but begun production step for the harness. So he has applied tape, but he has not applied the clip yet. And then we should see now. So he has applied the clip, but has not finished the process totally. Cut away the end of the clip. So from a manufacturing point of view, this is fantastic because you have control over the process. You can stop the production process, but also you have full traceability of the production process itself, which is very important towards the customer because he will then, in automotive, this is clear, there's 500 cars built per day of this car. We will be able to analyze defects extremely efficiently if we are able to reconstruct the production process without taking videos all the time, right? This is possible with a relatively simple product compared to the product you've seen before. I'm not sure if the hardware necessary to actually facilitate applying this model to the full harness we've seen before. So what's my summary of this? We said before we are here, operational, we are not yet systemic, but we already found that our employees are very much AI savvy. So IIT had to react. We had to ban all those external AI solutions supporting the work. So it's not the workforce which is not AI ready, I have to say, right? The organization even have to protect itself from that momentum everybody has at the moment. It is, for us, the nature of the product that stops us. Or let's put it in another way, as a plant manager, there is no return on investment. Does it really make sense to train an AI for 1 year and under which circumstances? Or does it make sense rather to work here in Vietnam with the Vietnamese workers and continue that kind of business? That is the big question I have to, and every plant manager, I think, have to decide. So, reality check, AI in manufacturing, and we heard this before, is really the best technical solution, AI? Is automation maybe better, or maybe even manual work, as we do at the moment? Are the benefits really higher than the invest and running cost, which is not only interesting for the controller, I believe? And that's important, that's my personal learning. Is the process and product simple enough in terms of has low variation in order to economically develop an AI model, which can then be used? And different aspect also, is the process stable enough? So is the output predictable? I'm speaking now here in statistic terms. The more outliers I have in my process, the more difficulties the AI model will have to work with that. The more supervision I have to put into my AI model. And like in every complex technical project, there's constant changes in the product and sometimes also in the process. And how easily can any AI model that we have developed change with the change of product or process? Those are the big questions that at the moment, in my opinion, stop us from driving or spearheading, let's say, the AI revolution. Good. With that said, my opinion about AI in manufacturing, especially in the automotive sector where I'm living and working, I have to say, here in Vietnam. If you have any questions? Yes.
Yeah, hello everybody. Firstly, my name is Wang. I come from Than Lap Company. I have got question for you. Essentially, one question. Yeah. Regarding the factory environment, what signification electromagnetic interference and vibration? How many percentage accuracy of data collecting from sensor?
Okay, I think this is a field I've understood, interference through electromagnetic influences. This is low voltage cabling, this is not electronics, so my factory is not that affected, but thank you to bring that topic of accuracy up. So the models we have seen have 95% accuracy, we have learned. In automotive, this is impossible to accept. In automotive, you are measured by parts per million. So when we deliver 1 million parts to BMW, for example, we are allowed to have 200 defects. We cannot reach this figure with 95% accuracy. So this is another problem we do see in AI, and this is why we cannot hand over the whole quality inspection, quality assurance to AI, because at its current state, it's not precise enough.
Okay.